Alright, we're going to do something I've been meaning to do for a long time, and I want to make this very clear. I'm doing this video in the way that I would want to hear it, because I will listen to this over and over and over again until I get the information basically etched into my memory. This is highly important to me, and they say one of the best ways to learn is to teach. So today, we're bringing you this very, very rare Edison storage batteries pamphlet, book, guide. This is the cover. Uh, this is the rear here. The only steel alkaline battery manufactured in the United States is the one bearing the signature of Thomas Alva Edison. Okay, so what is the point of this? Okay, batteries are known to be an item that have to be replaced, okay, in our contemporary understanding. These batteries, no one's determined the lifespan of them. They've lasted that long. In physics, most batteries, the degradation is known, and they can tell, how long they're going to last. With these, not so easily done. The way I have it in my mind, this may or may not work out truthfully, but most people know about lead-acid batteries. They're the ones you commonly find in auto parts stores and vehicles, things like that. There's some other high technology batteries like lithium ion and a bunch of other batteries and things like that that use other things other than lead, but they share the commonality that they will fail after so many cycles. So here's where I get to the part where I'm trying to understand this, okay? With lead batteries, they're lead acid, as in the acid and the lead interact, and gradually the lead becomes degraded from the acid to the point where it doesn't hold a charge, and then you're done. Well, with the Edison alkaline battery, there's no degradation due to reactions between oxidization and things like that, to where it's damaging the components. But you do have to change the electrolyte. But that's mitigated, to my understanding, with a mineral oil top layer floating on top of the electrolyte, because the electrolyte by itself absorbs, this is my layman's understanding, absorbs carbon out of the air, and eventually it wrecks the electrolyte's ability to transfer what we know as electricity. So anyway, enough BSing. Let's get down to this book. I'm going to basically read it to you, and I'm going to show you the pictures, and it's basically story time. But trust me, I've looked up and down the internet, and nobody has this book in any form, and so I'm going to remedy that. Hopefully, I plan to scan it and put it in my eBay store. It takes some time because I'm overwhelmed, but if you're interested in such a thing, leave a comment below, and this is, if you're seeing this on YouTube, on a format where you can leave a comment, let me know if you'd be interested in buying a digital copy of this book. But essentially, you're going to get all the information today if you stay with me. So, without further ado, and that was a lot of ado, let's get to it. Okay. So, first page. And these pages aren't numbered. Oh, yeah, they are. The first couple pages aren't numbered. Okay. So, industrial storage batteries. That's kind of easy. I really like the font of this stuff. For the typeset and the font, I really like it. It's not Art Deco. It's a little older or a little newer than that, but I think it's Metal Age. I'm not too clear. Okay, next page. The Edison nickel iron alkaline storage battery. Edison Storage Battery Division, Thomas A. Edison Incorporated, West Orange, New Jersey. A monograph prepared for the use of science and engineering schools. Wow, see? Oh, let me show you this page here. So you're not going to see this too clear, the written word, the printed word. So I'm reading it to you. Basically, when the pictures and diagrams show up, I'll try to get a good scan of those, or put it up to the camera so you see what you can visualize. This is a 640 by 480 VGA camera. It's not going to be that clear. Like I said, if you're interested in a real good scan of this, what I want to do is compile all the Edison knowledge I can find regarding the batteries, the alkaline batteries. He made a bunch of different other ones, but I'm putting it in my eBay store in a digital format, easy to use, easy to obtain. Not like trying to get original source materials. It is a pain in the... Okay. Copyright 1940, Thomas Alva Edison Incorporated. Printed in USA. Excuse me. There's going to be one take. I don't edit my videos. I don't have time for that. I wish I did. And skills. I'll eventually do that, but not at this rate. Because nobody subscribes. If you haven't subscribed, you're wrong. And if you can't subscribe because you're not listening on YouTube, you need to fix that. You're dorking us. Okay. Printed in USA. SB 3805 XVM. Copyright's 1940. Today is where we are. What was that page? That's impractical to show. I'm just gonna read this to you and just work on the. I'll flash it, but it's pointless. The resolution is crap. Today is the 6th month, the 11th day of 2017. 1940 was, well, from 1940 to 2000 is 60 years, plus 17. So that's 77 years. This is in the common people's... What's it called? The copyright is basically expired. The company's gone. It's done. It is open access, and this is educational. It's for educational purposes. So don't get all hung up on that. It's 77 years old. Public domain. It's public domain now. Okay, so preface. With the present edition, this monograph, issued originally in 1916 at the invitation of the Joint Committee on Physics as an aid to instruction in industrial storage battery practice, has been completely rewritten. Now, I'd like to see the original 1916 version. I don't have that. Okay, let's see what the changes are. Not only has the text been brought fully up to date with the latest developments in the uses of storage battery power by industry, but much new material has been added, including a series of exercises illustrating the characteristics of the nickel-iron alkaline storage battery and its usefulness. Sorry, there's pollen in the air. I'm getting a little haywire here. Hay fever. Usefulness in practical industrial application, such as the technical student will meet following his graduation. Wow. Doesn't say his or her graduation. It says his graduation. That's some 1940s talk. Aside from the purely scientific significance of the nickel-iron alkaline type of storage battery, its practical educational value lies, first, in its use as a DC, direct current, power source in the science departments for the laboratory demonstration of the principles of electricity, magnetism, and physical chemistry, and second, in the engineering departments as a means of instruction in practical storage battery operation. Its value in the latter case arises from the widespread and growing use of storage battery power in industry, and from the fact that in many classes of industrial service, the majority of the storage batteries are of the nickel-iron alkaline type. Times have changed. Okay, next page. Storage batteries in industry. So we got a big old picture of Thomas Edison. Oh, this is, see, the camera is hard to, well, you see his picture, right? Okay. You know how a camera is like backwards or something, how it records? So all my movements, like I'm on my hand left, but on the camera it's moving right. So I'm trying to do this right. There we go. I'm not trying to make it intentionally god awful, but I do need to digitize this, and so you can get a hold of it for a small fee on your part, and you know, for my labor and all that. So but anyway, let me get back to this. Okay, section 1, storage batteries in industry. So what I'm going to do, I'm going to read, there's a little caption on a little tab thing on this picture. I'm going to read that and show you the picture, then I'll get back to the text. Okay, this is for the picture. Storage battery power operates the industrial trucks that farm. Sorry, it's a little dark in here. I can't read this first pass, I guess, in some cases. Let's try this again. Storage battery power operates the industrial trucks that form the basis of modern material handling systems. Okay. Okay, so we got forklifts, right? Got some forklift movements, and you'll see this forklift again in this manual. Right there, it's rolling a bar. It's moving a roll of rolled steel, and it's picking up big old cases and things, wood crates. I'm sorry. The picture's gonna be wackadoodle. We'll work with what we got. The price is right? Okay. Section 1, storage batteries in industry. There is scarcely a product of American industry that storage batteries have not helped to produce in various ways. They furnish power for the locomotives that haul industry's supplies of coal, copper, nickel, and other basic materials between the underground veins where nature has buried them and the stations from which they are hoisted to the surface. They supply safe, modern electric light for the miner. They propel the battery industrial trucks, which are the basis of most modern plant transportation and material handling systems. They operate car retarders, switches, interlocks, and signals used in the classification and movement of railroad traffic. Examples of these and other industrial uses of storage batteries are described and illustrated with this text. The industrial uses of storage batteries are, of course, one of the results of the growing use of electric power, which dates back to 1882, when Thomas A. Edison opened the first commercial generating plant in Pearl Street, New York, and thus ushered in the age of electricity. It was the expanding use of electric power in following years that created the need for some means of using it. 1. In places where continuous connection with the generator is impractical. 2. At times when generator power is interrupted. Or 3. For actuation of equipment to which the generator current is unsuited. All the functions performed by storage batteries today in their many practical applications fall under one of these three classifications. Among the more important examples of the first of these functions are: 1. Propulsion of industrial trucks and mine locomotives. 2. Current supply for electric safety miners' cap lamps, watchmen's lanterns, manhole lamps, and other portable lighting equipment. Use of storage battery power for the propulsion of industrial trucks is a result primarily of its dependability, low cost per ton mile of work done, and freedom from the noise, smoke, fumes, and fire hazard of other forms of power. Its economy is due partly to the small number of moving parts in an electric traction motor and resulting low repair expense, and partly to the fact that the truck starts instantly yet consumes no power while standing. The latter is important because of the frequent stops inherent in this type of service. They're talking electrical vehicles. Okay, so I'm going to show you the pictures first and read you the captions, then show you the pictures. The Edison electric cap... I need to learn how to talk. The Edison electric cap lamp has greatly reduced mine disasters, gives the miner high levels of illumination directly on his work. A storage battery trammer in a metal mine. A storage battery gathering motor in a coal mine. A coal cutter operated by Edison storage battery in mine locomotive. And this is a caption for the ship picture. Ships. Pictures. The Edison continuous current system, together with an Edison storage battery, furnishes dependable electric power and light on shipboard. Okay, so we'll go through these little pictures. I know it's frustratingly not that clear. It's going to be a ding-dong to scan this because of the way this book is made. It's not made. The pictures go all the way down into the spine. That's going to be a real ding-dong to scan this sucker. Okay. Backwards again. So you got like yachts and freighters and cruise boats and whatever. Basically, lighting and navigation stuff. It's good for that. Okay, let's get to the reading. Where's my hand on this? Right here. In mine locomotives, storage battery power saves the expense of trolleys, feeders, and track bonding obviates losses from line to voltage drop in remote parts of the mine and reduces demand penalties, whether in the form of higher rates if power is purchased or in the form of higher generating capacity if the mine furnishes its own. This is due to the fact that battery charging can be done in off-peak hours and in any case is a uniform load compared to the fluctuating load when power is transmitted directly by trolley. Battery locomotives also eliminate trolley arcing and, when built to specifications prescribed by the Bureau of Mines, are the only type of power traction equipment which the Bureau certifies as permissible. In both industrial trucks and mine locomotives, the duty cycle of the battery consists of one shift daily. I'm sorry, I gotta comment on this. Ships and shifts. I mean, it sounds like I'm cussing. I gotta be really enunciating on this stuff. Okay, let's get back to this. In both industrial trucks and mine locomotives, the duty cycle of the battery consists of one shift daily, usually either of 8 hours when that is a working day, or of 12 hours when the traction unit is in continuous operation. In the latter case, 2 batteries per traction unit are used when being on charge while the other is at work, so they're hot swappable. That's still used today. This requires less frequent battery exchanges, affords a reserve for emergencies, which may be realized by exchanging at 8-hour intervals, and normally permits ample time for cooling and flushing prior to charge, which is completed usually in 6 to 7 hours, thus allowing 5 to 6 hours out of 24 for that purpose. My understanding of that is they have a generator going, like at a mining site, and hook up a Edison battery bank to it, while having another Edison battery bank powering, that little mining cart mover thing, and then they just swap it out at intervals. In such applications of batteries, charging is the principal regularly required maintenance operation. In Section 3 of this monograph, experiments and exercises are outlined which are intended to my battery's low, apparently. Intended to familiarize the student with the subject. Okay, next page. Oh, we're going through the rigmarole again. I'm going to read the picture captions and show you the pictures, and then you read the big old text, okay? The light weight of the Edison battery makes possible maximum payloads on modern smart delivery trucks. Smart vehicles back in 1940. Edison, after 5 days and nights of labor perfecting his phonograph, the granite plunge cell is at the left. The granite plunge cell is at the left. That must be a famous cell that I have not learned about yet. That might be something to check out. Okay. On passenger trains, Edison alkaline batteries supply standby power for the operation of lights and air conditioning equipment. They are carried in a compartment beneath the car. And then it says right, like the picture. More captions. There's something called a car retarder. It looks like something to do with railroad tracks, some kind of switching or stunning thing. I don't know. There's an interlocking plant and a light signal. And I'll read what's on the electric delivery track. It's Dugan's, Bakers for the Home, New Jersey, Pennsylvania, wheat bread, and new Southern loaf. So it's a bread delivery truck van. Delivery guys out there. That picture is Edison with that cell, which I already forgot what it was. I think it's that cylinder next to his elbow there. Something to check out. That's the light signal. You see a train, the nose of a train and the light signal. That's the interlocking plant. And that's the car retarder. I don't know what that is. There's just some Edison cells sitting on the undercarriage. Right there. And then that's a big old train. Okay. Examples of this second storage battery function are 1. Steam, railway, passenger car, lighting and air conditioning. 2. Electric railway, multiple unit car control. 3. Electro-hydraulic steering controls, lights, and other electrical equipment aboard ship. 4. Railway signals. 5. Airway beacons. I've heard of Airway Heights in Spokane. Oh, my nose is itchy. Sorry. I've never heard of airway like railway though. That's interesting. Sorry. This is real life, okay? It's a hobby of mine. When I have time, I finally have some time. Look at me. I'm so excited. Even though this video is not picture perfect, we're going to go on and get it done because when am I going to have time to do this again? Apparently it takes like months to have a little bit of time to do something like this. Okay, in such applications, the storage battery is usually connected into the circuit with the generator and the loads so as to be maintained in a normally charged condition and supply the loads whenever generator power is interrupted. In a railway passenger car, for example, lights, air conditioning, and other electrical equipment are normally supplied with power from the axle generator when the train is at normal speeds and from the battery when the train is running slow or at a stop. Little information I heard, cabooses at the end of trains, there used to be caboose, the caboose car, they were filled full of the Edison batteries. And you no longer see cabooses on the caboose on trains. That's a thing of the past. So they have different computer controlled dealy bobs to do what the caboose used to do. The duty of the battery is irregularly. I used to be such a good out loud reader. I don't know what's worse, me complaining about my skills or me just messing up. An example of the third storage battery function is meter testing and calibration, which demands a wider range of voltage and current values than is readily obtainable from a single generator. I live next to a church. At the time, these various industrial uses of storage batteries aroused Mr. Edison's interest. The lead-acid type of storage battery had already seen considerable development. It dates back to the 1850s when Plante a French experimenter discovered the reaction between sulfuric acid and lead, which is the basis of its operation. It is in extensive use today for the starting, lighting, and ignition of automobiles, and for that service it is recommended and sold by the Edison E-Mark division of Thomas A. Edison Incorporated. So, I say Edison batteries, but you gotta say Edison alkaline batteries, okay? And even a tertiary nomenclature that would be Edison alkaline nickel iron batteries, because Edison company later made uh, Edison alkaline nickel cadmium, Canadian, anyway, sorry, Canadian cadmium. Okay, let me go over that again. So when I'm talking about these batteries, okay, all right. In a nutshell, Edison batteries refers to a whole slew of batteries because they made just about every type that they ever came up with to that point. Okay. What I'm talking about, though, is out of that family of cousins of batteries of different chemistries and types. I am specifically referring to the Edison alkaline nickel iron type, okay? When I'm saying all these wonderful features. A kissing cousin is the Edison nickel iron, sorry, is the Edison nickel cadmium type. Similar characteristics, possibly better, possibly other things, but that cadmium became a banned a substance considered highly toxic, and they quit making them. I don't want to be around cadmium personally. I don't want it. I don't want it around. Um, to me it's an unneeded material for what I want to do. So I'm after, and I was focusing specifically, and if I put on my eBay information regarding this, it'll probably have all the different, or it'll probably have a lot of information on nickel alkaline and nickel cadmium, because they're so similar in what they require to run. We're talking electrolyte and all that. So it's probably going to have information on both types, but my focus is going to be on the nickel iron alkaline Edison battery, okay? And you'll see when you're trying to get a hold of these, they'll be called NIFE, N-I-F-E. That's the atomic table, nickel and iron. And there's the type I'm not too interested in at all is the nickel cadmium. Those are NICAD. And interestingly enough, those were continued in other formats in the closer to our time. The NiCad battery packs and things like that. That I think they developed for, space program and things like, whatever. I'm talking, but those things, I'm getting, my brain's tired. So, anyway, what I'm trying to get at is there's nickel cadmium batteries made to this day. They're different from the Edison nickel cadmium. But that does not pertain to what we're trying to explain here. We want the Edison nickel iron alkaline battery. Okay, something else you need to know too. The NIFE atomic table designator was taken as a trademark or a trade name is knifey, N-I-F-E, knifey, and it's in an oval. And they continued to make batteries under NIFE, but they were not nickel iron. They were nickel cadmium, but they say knifey on them to further confuse you or further confuse themselves. So you'll see as battery, it'll say knifey on it, and you'll say, oh my gosh, that's nickel alkaline. That's the one I want. But it'll actually be nickel cadmium because they've taken the atomic nomenclature and turned it into a trade insignia, intended to or unintended to, and then you think you're buying one thing and you're getting something else. I almost bought something like that. That's how I know. I looked it up. I was floored because this is all very confusing to somebody that's first learning about these batteries. So I'm saving you some headaches. Alright, can we get back to reading this thing? Okay. I forgot my spot. Thanks. Okay, I'll just... Should I start it over again? Yeah, I'll just start over again. We got time. Examples of the stored... I don't want this video to become garbage. Okay. Examples of the second storage battery function are 1. Steam railway, passenger car, lighting and air conditioning. 2. Electric railway multiple unit car control. 3. Electro-hydraulic steering controls, lights and other electrical equipment aboard ship. 4. Railway signals. 5. Airway beacons. In such applications, the storage battery is usually connected into the circuit with the generator and the loads so as to be maintained in a normally charged condition and supply the loads whenever generator power is interrupted. In a railway passenger car, for example, lights, air conditioning, and other electrical equipment are normally supplied with power from the actual generator when the train is at normal speeds and from the battery when the train is running slow or at a stop. The duty of the battery is irregular and usually consists of partial cycles. It is commonly spoken of as standby service, meaning, as the term implies, that the battery stands by ready to assume the loads at any time. An example of the third storage battery function is meter testing and calibration, which demands a wider range of voltage and current values than is readily obtainable from a single generator. At the time, these various industrial uses of storage batteries aroused Mr. Edison's interest. And by the way, it's Mr. Edison. He did not get a degree from anywhere. He was self-educated. Something to think about. At the time... I wonder if he could talk. I know he couldn't hear very well, but I wonder if he could talk better than me. Probably. At the time, these various industrial uses of storage batteries aroused Mr. Edison's interest. The lead-acid type of storage battery had already seen considerable development. It dates back to the 1850s when Plante, that's the last name of this guy, a French experimenter, discovered the reaction between sulfuric acid and lead, which is the basis of its operation. It is in extensive use today for the starting, lighting, and ignition of automobiles, and for that service it is recommended and sold by the Edison E-Mark division of Thomas A. Edison Incorporated. So I already read all that. I just read it again twice. Now I remember. There's a little bit on this next page. But it is relatively short. But it is a relatively short-lived type of storage battery and lacks a high degree of durability and operating dependability of the nickel-iron alkaline type. So that means your car battery is going to last a couple of years. I just helped a friend replace their battery. Her battery lasted like 6-7 years. It was a highfalutin Volkswagen original source battery for a Passat. OEM. So you know, they're talking these lead batteries. You will have to replace them. They eat themselves. Um, in Mr. Edison's library, there hangs an oil painting of the inventor and an early model of the phonograph, beside which stands an old-time primary cell of the type known as the granite plunge cell, which actuated the phonograph's motor. Okay, so that's what it was. The elements consisted of carbon and zinc, the electrolyte of a solution of sulfuric acid. So that was a carbon zinc battery, see? He was all over the place with battery types. But his opinion was the nickel alkaline nickel iron alkaline was his favorite. Okay, next page. I'll read the captions. Magnetic track brakes on steam line street cars work from dependable Edison battery power. Chronograph, Edison battery actuated. Edison batteries on meter calibration bench. Edison power for teletypewriter. I use a teletypewriter in the Navy. Those suckers are like a fax machine on a radio. Oopsie. Okay. Oh, what? Oh, the page flipped. Sorry about that. Let's flip it to the next couple pages. Okay. Well, there's more captions. Sorry. I'm getting a little groggy. On New York subway systems, storage battery power operates the world's largest private telephone exchange. Left. The picture to the left. Prevents stalling of elevators if line power is interrupted. Left below. It's not a joke. It's the left below picture. And actuates the traction motors, brakes, doors, and emergency lights of the trains themselves. Picture below right. Few uses better illustrate the dependability of alkaline batteries. Okay. Oh, my hand. My hand's covering. Okay, so you got some operators. There's a big old battery bank right there. There's a train. Electric subway train. The battery bank's probably on the elevator. That must be elevator pulleys or something. There's a teletypewriter with some Edison nickel irons. Yeah. So yeah, if this aggravates you, just leave a comment, and I'll depending on how many comments, if there's interest, if people want to get a hold of it, and what kind of price you're looking for. I'm just saying maybe $20. It'll have so much information. You won't have to suffer through my bad pronunciation and stuttering, and you'll have a clear copy you can use it for your own purposes. Because, frankly, these old manuals, there's not enough to go around. Everybody can't own one. They're in short supply, so someone's going to have to figure it out, digitize them, so provide them to the masses, right? But it's not like the masses use these batteries anyway. They're unheard of. You are going to be in an elite club that understands this technology existed. It still exists to this day, which, you know, some people would say, hey, why are you letting the cat out of the bag? Well, hopefully people will start realizing these suckers are something you hang on to, and they won't get destroyed. I'd rather everybody know about them and cherish them, kind of like something like a family heirloom or something, and they won't get scrapped and crap for scrap value. I'd rather that they would get out as knowledge. Hey, don't destroy these. They're worth something. They're restorable. Than to have we play hush hush and then tons of these things get destroyed for dumb reasons. Because people are like, oh, what is this? An old battery? No way it will work again. Because they're assuming that all batteries die for good, and this type of battery apparently would outlast the owners. So here we go. The zinc electrode was arranged so that it could be pulled up out of the solution when the cell was not in use, as otherwise it would be eaten away by the acid whether the cell was furnishing current or not. It is to be remembered. So basically, Mr. Edison was traumatized by acid eating up his batteries. So he looked for a different way. It is to be remembered that in his experiments on both the phonograph and the incandescent lamp, Mr. Edison employed primary batteries as a source of current because the first commercial electric power plant was yet to be opened. At any rate, the difficulty of controlling so active a chemical agent as sulfuric acid and the fact that lead is not a good structural material, it's a soft metal and it's heavy, are to be numbered among Mr. Edison's objections to the adaptability of the lead acid type of battery to industrial applications. Beginning in 1898, he conducted the most extensive research he ever devoted to one invention, and 10 years later brought forth the nickel-iron alkaline type of storage battery. Everybody knows about his light bulbs, but not everybody knows about his battery, which his research culminated. I'm one of those people that have read so many words that I've never said out loud, and that's one of the accumulate. We'll say the sum total. So his research was heavy duty in these batteries, and you probably have all kinds of neighbors and cousins, uncles, never heard of them. Not you though, you're learning. Or you probably already know, and now I'm just greasing your wheels. Okay. Or maybe I'm just irritating you. Maybe you got nothing better to do. Maybe you're drunk and you're watching YouTube one late night. I don't know. But thanks. Thanks for your attention so far. You know, as an aside, I cannot watch myself. I break out into hilarious laughter. Like in uncontrollable hilarity ensues if I try to watch myself. I don't know what it is, if it's psychological or what. I cannot watch myself on YouTube. My personal self, I cannot watch myself on YouTube. I'm too funny to myself. I don't know what it is. So I'm able to listen to myself, you know, but I cannot watch myself without laughing and laughing. I don't know why. I'm not that funny. Don't you laugh. Don't you laugh. No. Don't do it. That's to me. The hilarity needs to end. Alright. I lost my spot again. No, I didn't. I know where we are. Okay. Although many combinations of electrodes and electrolytes have been tried, only two types of storage batteries, the lead acid and the nickel alkaline types, are in commercial use today. This is in 1940. Now that nickel alkaline is a rare bird. It may be coming back though, thanks to people doing stuff like this. Both are based on the principle that chemical action can produce current discharge, and conversely, that current can produce chemical action charge. Nearly everyone has had the experience of stepping on the starter of his automobile only to find that nothing happened. The battery, which may have seemed as good as you... Okay. Alright. Nearly everyone has had the experience of stepping on the starter of his automobile only to find that nothing happened. Got a big old loogie. Hold on. Alright, so I'm not a robot, right? I got things that happen that I gotta take care of. Okay? Right? So, let's get back to this. It's real life. I wonder how those lecturers that talk for hours and hours at their podium, what if they have a loogie? What if they gotta pee? I'll take care of both right there, okay? You want to know what happened? For the historical reasons, I'll tell you the truth. I had to take a little break. So, where were we? I should be a lot clearer now that things have been resolved. Nearly everyone has had the experience of stepping on the starter of his automobile only to find that nothing happened. The battery, which may have seemed as good as usual, only the day before has gone dead. And that's done with quotations, gone dead. That's how it's written on there. Okay. There are numerous industrial applications in which unexpected failure would have more serious consequences. Failure of an industrial truck battery can cause expensive production tie-ups. Failure of a battery serving the control circuits of a subway train or furnishing standby power for a ship's steering mechanisms might even endanger human life. In all standby applications, the storage battery serves as an insurance of unfailing continuous operation of a wide range of electrical equipment in which reliability is the prime essential. Whether the emergencies against which it is expected to stand guard are of frequent or infrequent occurrence, it is of the utmost importance that the battery, regardless of the overcharging that is virtually unavoidable or the mechanical shocks and vibration that are frequently incidental to the service, can be depended upon to assume the load instantly. Many of the more exacting industrial applications of storage batteries of today had not yet appeared at the time, in 1898, which Mr. Edison suddenly announced that he was going to hunt for, quote, nature's secret of a good storage battery, unquote. They serve, however, to emphasize the breadth of the commercial need for a battery of unfailing dependability which he then foresaw. Details of the improvements in durability and operating dependability which he achieved in the nickel-iron alkaline type of battery are given in the next section of this monograph. Ooh, we're getting to the juicy part. So I'm going to read the little captions for the photos. All types of package energy. In addition to his invention of the nickel-iron alkaline type of storage battery, Mr. Edison supplemented the work of earlier experimenters and developed the Edison primary battery. Subsequently, manufacture of the Edison dry cell and the Edison E-Mark battery was inaugurated, making Thomas A. Edison Incorporated the only American manufacturer of all the types of electric batteries, both primary and secondary, which may be regarded as of major commercial importance. Below, like picture below. Typical Edison storage batteries for large trucks in operation 24 hours a day are shown in the battery room of a steel mill. Batteries are being exchanged. So it looks like they have a forklift type vehicle turning the batteries pack on the back out. So here's it. And the next page is a list of features, good things about these types of battery. The Edison, I'll read it here in a sec. So those are the others. The one in the middle looks to me like a nickel iron alkaline. The other two are different types that frankly aren't going to last you. And so why would they make them? Because like starter batteries for a car, you get amps, high duty amps to start a starter. But then as the offset, it does wear out over time. I remember he was trying to get alkaline starter batteries too to resolve that, but the price points and stuff kind of got out of. Well, that's another story. So that's that forklift steel mill thing, and on the top, the front of it, not where the guy is, but the front of it, that's where the roll of steel would be moved around. It's just literally trading out a battery pack. And this other part right here, I'm going to read you that. The outstanding advantages of the Edison storage battery. Each of these important advantages is attributable to the rugged construction and the operating principle of the Edison nickel-iron alkaline storage battery. 1. It is light in weight, and that's compared to lead batteries. 2. Its nickeled steel container is unbreakable. 3. Unlike other types, it is easy to lay up. That means like mothball, put in storage. Merely discharge it to 0 voltage and short circuit. It may be left standing in idle in this condition indefinitely without injury. 4. It may be short-circuited without injury. 5. Unlike other batteries, an accidental charge in the reverse direction will not injure an Edison battery. 6. It is entirely free from ordinary storage battery diseases like sulfuric acid eating up the plates. 7. Freedom from corrosive acid fumes permits its installation in close proximity to employees and to delicate apparatus. 6. 8. We're on 8. 8 is not damaged by freezing. 9. Its electrolyte is a preservative of steel. 10. There's steel in the case, so it preserves its own casing. 10. It increases in capacity during the first 2 years of service. Now, people have commented on that, how the batteries get stronger, and it's some weird science. 11. It requires no internal cleaning, the active materials being held securely in perforated, nickeled steel tubes and pockets. 12. Its steel cover is welded permanently to the steel container, indicating inconclusively that no... Okay, I threw a word in there where there wasn't one existing. I'm going to read that again. 12. Its steel cover is welded permanently to the steel container, indicating conclusively that no internal repairs are expected. 13. Its tray assembly and cell connections are extremely simple. 14. It requires no spare parts. 15. It does not require equalizing charges. 16. It requires no renewals of separators throughout its long life. 17. Its life is so long that the annual depreciation figure is lower than that for any other type of storage battery. Now they're dancing around the fact that they don't know how long these last, right? We still don't know how long these last. We're talking craziness how long they last, right? That they don't tell you because they don't know. We don't know to this day. It's just basically the going thing to say is they will outlast you. Okay, next page. This is cool. This is a really good data table. So it's called Data on Edison Cells. I'll read the text and I'll show you the chart, but I'm not reading each little deal. But this is a list of in 1940 all the different designs they had of these. I saw a magazine ad that showed like a skyscraper type, which is like really high and thin. I don't know if it's on here, but there's quite a selection. Okay, I'll read the little asterisk things. So one asterisk says the letter quote H unquote indicates capital H, indicates high type cells. These cells have the same characteristics as the standard type cells, but are built higher so as to hold more electrolyte and are used in installations where frequent flushing is not convenient. We're talking about flushing electrolyte. 2 asterisks. Ratings are on basis of 5-hour rate for capital A, capital B, capital C, and capital N type cells, N as in November, and 3.5-hour rate for G and L type, capital G and L, capital L type, with average of 1.2 volts per cell and final of 1 volt per cell. The 3 asterisks. Weights are for completely assembled cells, including trays, connectors, etc. how Edison improved the storage battery. So let's get this chart into the video. And so just pause it on there where you see what you want to see. And you might have to do some patience and stuff for this chart, because I'm not showing it up on here very good. Are you getting that? I'll do a couple more passes and hopefully you get what you want to see. Because this will tell you what you're dealing with. That's like the Rosetta Stone to what you're dealing with when you find these batteries. And it'll be printed on the top of the battery, stamped into the metal. If it's one of these batteries. Okay. So what we're going to do, we're going to stop this video here. It's just past an hour. I need to take a break. No, we're going to keep going until it's over. Darn it, I almost did it. Because what happens, I take a break, then the day's over, and then I never get around to it. We're going to keep chugging on. Because that's the way I want to do it. I want it one big video. And then it's just a one-stop shop. You, however, go ahead and take a break if you haven't had one already. It's been an hour. Okay, so I'm going to read the caption. Edison nickel iron cell type capital A8, so I'll call it A8, cutaway to show construction detail. Container, grids, pull pieces, even the pockets and tubes enclosing the active materials are of steel. This results in great strength and durability, combined with light weight. The alkaline solution is a steel preservative. So this tells you the components. So this is a common, more common than you would think photo. You can find a better, or you'll find this online. But I'll read all the words and then I'll just show you the photo. There's probably clearer ones you can find. So there's a suspension boss, a side rod insulator, a side insulator, a negative pocket of iron oxide, a pocket insulator, a negative grid, a connecting rod nut, a spacing washer, a split washer, and there's several of those. It's just showing you one example of a whole stack of them. Gland cap, black, quote, negative, unquote, negative pull, lid spring, pull nut, cotter pin, hinge band, filler cap, valve, positive pull, gland cap, red, quote, positive, unquote, cell cover, welded to container, stuffing box, welded to cover, steel gland ring, stuffing box gasket, pull insulator, pull washer, spacing washer, split washer, connecting rod, positive grid, grid separator, seamless steel rings, positive tube of nickel metal hydrate, positive tube of nickel hydrate and nickel flake in layers, corrugated steel container, cell bottom welded to sides. So yeah, this is not going to be very clear. Sorry, I apologize. But you can find this online. I found it myself. Just type in cutaway nickel iron battery on Google Images and it should pop up. Okay, section 2, how Edison improved the storage battery. The advances in durability and operating dependability which Mr. Edison effected in the nickel-iron alkaline type of battery are readily understood by considering how its basic reactions differ from those occurring in the lead-acid type. In the lead-acid battery, the reaction producing current during discharge is sulfation. The positive and negative active materials are respectively a lead oxide and metallic sponge lead held in contact with lead or lead alloy grids, which are suspended in a sulfuric acid solution. Both these materials change to lead sulfate as the battery discharges, while the effect of charging current is to reverse the process and restore the lead oxide and lead with which the discharge reactions began. In the nickel-iron alkaline battery, the effects of the reactions are oxidation and reduction. During discharge, the positive active material, a nickel oxide, is reduced to a lower oxide, and the negative metallic iron is oxidized to form an iron oxide. Reoxidation to the higher oxide of nickel and reduction of the iron oxide to metal are the reactions of charge. In brief, the effect of the reactions can be described as a transfer of oxygen from positive to negative plates during discharge and from negative to positive plates during charge. Thus, the reactions do not appreciably change the density of the caustic potash electrolyte, which may be said to act practically as a conductor and an oxygen carrier. Its natural property of acting as a preservative of ferrous metals makes possible the use of steel for the structural parts of the cell. The first important difference to be noticed, therefore, is that the lead acid cell, the electrolyte alternatively, the lead my eyes are scanning faster than my mouth can talk, so sometimes I scan in something that's not what it is. Oh, how long is this thing? Oh, it's going to be long. Let's get through it. Let's get through this. This is historical. Come on. Come on. And then after this, I'm taking a nice sleep. I've been up all night. This is the morning after working all night. It's not the best time to do recording, but I want this done. I've been waiting. The first important difference to be noticed, therefore, is that in the lead acid cell, the electrolyte alternately increases and decreases in density with successive charge and discharge, which has the effect of rendering it susceptible to freezing when discharged, while in the nickel-iron alkaline cell, the nearly constant density of the electrolyte, together with its property of not solidifying at low temperatures, obviates the possibility of damage by freezing. Obviates. That must mean prevents. That's a new word to me. It really is. Obviates. Obviates. Or if it's cousin of obvious. Another difference is that in the lead acid cell, particularly those designed with high narrow plates and containers, rapid charge results in correspondingly rapid evolution from the plates of concentrated acid, which, having a high specific gravity, sometimes settles in the bottom of the cell and causes what may be termed stratification. The dense acid is injurious to the lower parts of the plate structure, while the lack of the normal quantity of acid at the upper part of the cell reduces the total available capacity. So this text goes on for a while, and then there's a cool diagram of the reactions. I'll just show you the reactions now. The diagram. And I'll continue reading the text. So where my hand is on there, my fingers, that is what's going on. Oh, come on, get on there. This is highly important. This is on here for reference. Because that tells you what's going on. Just pause it, put it where you need it. Hopefully you're getting that on there. That tells you what's going on. That tells you the chemical reactions. Okay, sorry. Let's get back. In the nickel iron, that's such a mouthful, but I'd rather say it than have an acronym. In the nickel iron alkaline cell, the fact that the reactions produce no appreciable net change in the density of the electrolyte renders stratification impossible. When a lead acid cell is allowed to stand in a discharge condition, the sulfate gradually coalesces into the form of large crystals, as is true of many salts when in a liquid in which they are more or less soluble as the temperature rises and falls. In this condition, they cannot readily be reduced by a charging current and eventually fall to the bottom of the cell as sediment. This explains why instructions for the care of lead acid cells usually emphasize the importance of recharging promptly and of maintaining inactive batteries in a charged condition. In the nickel iron alkaline cell, neither of the active materials is soluble in the electrolyte, and when the cell is in a discharge condition, no detrimental reaction can occur, so that it may be left in that condition indefinitely without injury and without need of attention. Still, another difference arising largely from differences in the mechanical construction of the plates is found in the effect of gassing during discharge. In the effect of gassing during charge. In the lead cell, oh man, I'm losing it. In the lead acid cell, the construction used to hold the active materials in contact with the grid structure, whether in the form of enclosing tubes and pockets as in the nickel iron alkaline cell, or in the form of porous sheets assembled tightly from adjacent plates, is limited to materials such as wood, rubber, or glass, which the acid does not attack. Steel, of course, cannot be used. It is difficult, therefore, to avoid loss of active material when gas bubbles formed in the plates break through to escape. As a means of avoiding excessive gassing, instructions for charging usually specify limits to the rate of charge called finish rates, which are to be observed during the latter part of charge. Gradual loss of active material from any cause usually is the final limiting factor in the life of a lead acid cell, and whenever the accumulation of sediment reaches the plates and short-circuits them, the cell fails. In the nickel iron alkaline cell, all active materials are securely retained within perforated steel tubes and pockets so that they cannot be dislodged even by violent gassing. In the design of the cell, it has been unnecessary as a consequence to provide the large sediment space usually found in lead acid cell containers. In the lead acid cell, considerable volumetric expansion occurs during discharge, particularly in the positive plate, due to the fact that lead sulfate due to the fact that lead sulfate is more bulky than the oxide it replaces. During charge, an equivalent contraction occurs. These volumetric changes are believed to be a further cause of gradual loss of active material. Because of the expansion during discharge and the fact that lead sulfate is not a good conductor, it is difficult to force charging current through the cell when too much sulfate has formed. Instructions for the care of lead acid batteries usually specify a limit below which the discharge must not be carried. So that basically means don't totally discharge your lead batteries, because it'll damage them. Do as little bit as possible, pretty much. In the nickel iron alkaline cell, volumetric changes are so slight that the cell can be completely discharged without injury. In fact, complete discharge to zero is recommended whenever the battery is to be temporarily withdrawn from service. The nature of the basic reactions of the nickel iron alkaline cell and their accompanying physical changes, as briefly outlined in the foregoing, results in numerous practical operating advantages, with many of which the student may familiarize himself by conducting the exercises outlined in the next section. So, next page has a picture of Mr. Edison. I'm going to read the little caption. Photograph of Mr. Edison taken in his West Orange laboratory, where the nickel iron alkaline storage battery was invented and perfected. And in science and engineering laboratory use on the other page. I'm trying to do this here so you can see. Did you get a good look? Did you get a good gander? Okay. We're almost done. We are almost done. I'm telling you. Thank you for hanging out this long. That means you are a trooper. Section 3, in science and engineering laboratory use. There's no pictures on this one. It's just me stumbling over my words. The nickel iron alkaline type of storage battery is widely used in school and college laboratories, both 1. In science departments as a DC supply for instruction in electricity, magnetism, and physical chemistry, and 2. In engineering departments for demonstration of the principles and methods employed in the practical uses of storage battery powered in industry. As a laboratory DC source, this type of battery has the advantages of long life, low annual costs, and dependability, which are the principal reasons for its wide usage in industry. More specifically, its ability to stand idle without deterioration when in a discharged condition is a great convenience, eliminating, as it does, the need of periodic charging or other attention required by the lead acid type of battery during vacation periods. Its lightweight and durable steel cell construction are useful features in portable batteries, while its ability to withstand overcharging permits tapping a variable number of cells in order to obtain variable voltages as required without risk of injury. During subsequent charging, the cells that have been discharged the least must withstand a certain amount of overcharging in the course of bringing the others to a fully charged condition, but this does not cause damage in the nickel iron alkaline type of cell. For use in science departments, I was checking the time on this, it's like almost an hour 30. For use in science departments in which the function of the battery is solely that of furnishing DC supply for the conduct of experiments, there are two ways in which the cells may be installed. A single battery, frequently of 100 cells or more, is connected through a switchboard and wiring system to the laboratory benches, thus making available a wide range of voltages. The other method is to use portable sets. Each method has advantages of its own, and in large laboratories both are often used. Generally, however, portable sets have proved more satisfactory. In the use of a single central battery, the large amount of secondary wiring necessary to distribute the current from a common switchboard usually increases the investment unnecessarily without adequate compensatory time. Without adequate compensatory compensation satori compensatory saving of time or money in other respects. A complete discussion of the installation of a DC power of a D. I'm falling asleep. A complete discussion of the installation of a DC supply for the science department laboratory battery is beyond the scope of this monograph. This company's sales engineers, however, are at all times available for consultation on request to any of its branch offices or to the home office. Likewise, I gotta get some water. Getting dry mouth. Likewise, it's like ticks on a hog. Okay. Likewise, a list of science experiments employing electric current is considered beyond the scope of this booklet, as it is believed that the science instructor will prefer to formulate his own or to use those prepared by recognized authorities. On the other hand, the available authoritative literature relating to laboratory instruction in battery characteristics and their significance in practical industrial battery operation is much more limited. It is believed, therefore, that this is a subject on which a discussion will be welcomed by both instructors and students in engineering colleges. Instruction in this subject, while probably of greatest value to those pursuing courses in electrical engineering, is of value also in mining and mechanical engineering, since storage battery power is used extensively in mine haulage, as well as in the transportation and material handling system of the industrial plant. Those expecting to enter marine architecture will also benefit, since storage battery power is used on shipboard as a standby source for lights, hydraulic steering engines, and other purposes. A study of the industrial uses of storage batteries, as given in Section 1, will also be useful in indicating the various fields of engineering into which their application and operation extend. An excellent form of instruction consists in assigning the maintenance of a laboratory battery of laboratory batteries to the students. In this way, they will learn many details of the care of batteries in commercial use. With the possible exception of neglecting to flush and allowing the electrolyte level to fall below the plate tops, it is virtually impossible for the beginner to do anything that will cause permanent injury to the nickel-iron alkaline type of cell. The following experiments and accessories. Are you enjoying this? I hope so, because it is total force of will to get through this. The following experiments and exercises have been selected to demonstrate to the student some of the more advantageous characteristics of the nickel-iron alkaline type of storage battery. These advantages contribute in no small measure to its wide commercial acceptance. Exercise 1. Physical characteristics. Strength. There's an asterisk and script that says, one asterisk. An alloy of lead and antimony is also employed. Okay, so the structural parts of the cell which must withstand the mechanical shocks and stresses incidental to practical use are mainly the cell containers, the pole pieces, and the grids which support the active materials. In the lead acid type of cell, containers are usually made of hard rubber or other molded acid resisting material, and the pole pieces and grids of lead. And then there's an asterisk, and I'll read it again. And asterisk says an alloy of lead and antimony is also employed. In the nickel-iron alkaline type of cell, containers, pole pieces, and grids are all of steel. From a mechanical engineer's handbook or other suitable reference source, obtain the tensile strength in pounds per square inch of hard rubber and lead. Then look up and compare with the tensile strength of lead. So they're basically saying that lead is much softer than steel. How much more? Okay, look. Okay. We're at an hour 30. We're going to continue this in part 2, okay? I'm literally like falling asleep. I'm exhausted. So let me get this taken care of. I don't want this so big that I can't upload it. Alright, stand by.